Okay, our last tutorial is going to be on diverging mirrors. Of course, you don't have to watch this in the order I did them, but this is the last one in the order I did them. So for diverging mirror, I have my object out here, and I first make my parallel ray, starting at the tip of the object, going parallel to the principal axis until I hit the mirror. You'll notice that the mirror, I have the little vertical line within the dashes at the edges to tell me it's a diverging type. If it's diverging, the focal length is on the opposite side. It's a negative focal distance. The center is also at the opposite side. So this is going to reflect through the focal point. Well, it can't really reflect through the focal point. Instead, it's going to reflect as if it came from the focal point. And too close to the edge. So it's going to reflect like that. Remember, only the left-hand side is where the light is. The right-hand side, that's extrapolation. So there is my parallel ray. Let's go to the focal ray. The focal ray starts at my object and goes to the secondary focal point, which is the same as the principal focal point. But, of course, when it hits the mirror, it reflects back, and so it's going to reflect back like this. Well, clearly this reflection is not going to meet the magenta reflection for the parallel ray. So I'm going to take this and extrapolate the other direction. For my vertex ray, the vertex ray starts at the tip of my object, goes through the vertex, and when it gets to the vertex, it's going to reflect symmetrically. So count how many up I was. I was 1, 2, 3, 4, 5, 6, 7, 8 boxes up. So 1, 2, 3, 8 boxes down, and the reflection is going to go like this. And then finally for the center ray goes from the tip of my object to the center of curvature, and then it reflects back along that same path. One of the important things here is to remember which ones of these are extrapolations and which ones are the actual rays. So let us put dashes so we know which ones are which. So I have everything on the right hand side has to be an extrapolation. So those are all extrapolations on that side. And on the other side, do I have an extrapolation? Nope, everything there was good. Now keep in mind then that the direction that the rays are actually traveling here was like this, and then back like this for the center ray. For the parallel ray, it was going like this. For the focal ray, it was going like this. And for the vertex ray, it was going like that. Well, of course, where is my image? My image is where those extrapolations met. So the extrapolations were all pretty close to each other. Good job this time. And so there is my image. So I had my object and my image. This image is upright, virtual, and diminished. Upright because the arrow is going the same direction as the object arrow was. Virtual because it's the extrapolated rays, not the actual rays. And diminished because it's smaller in size. For a diverging mirror, you will always have the image formed is an upright virtual image that is diminished, that is between the mirror and the focal point. So that concludes this tutorial on diverging mirrors.